Alaikum and welcome to the second part of our lecture about IPv6. IPv6 address classified into three main types denoted by multicast, unicast, and anycast. It is noticeable that broadcast address is omitted from IPv6 address as main category and deployed the multicast address to support broadcasting operation instead. Also, Unicast is a new address type in IP version 6 compared to version 4. Our focus about global unicast address, which are routable and reachable addresses across the internet. For example, here, the two halves of IP version 6 address, the left hand side 64 bits, which are network ID, can be divided into three parts: ISP, site, and LAN. Then the ISP represented by 3 bits supported by IANA to the unicast address, which is 001. Then the 29 bits, which are global prefix, all merged to represent the ISP 32 bits part. Then the site address, which is 16 bits, supported through service level agreement as a site. Then 16 bits LAN and subnetting within the site to support the interfaces, which is 64 bits on the right. For example, in our University of Baghdad, we can imagine that our students represent interfaces IDs that belongs to a lab or LANs with 16 bits each. Each LAN connected to a site, which is University of Baghdad. Then the site of University of Baghdad supported by an ISP, for example, Earthlink, Internet Service Provider in Iraq, which uses global prefixes for their routing operations. The global routing prefix is assigned to a service provider by Internet Assigned Numbers Authority called IANA. The site level aggregator SLA or subnet ID is assigned to a customer by their service provider. Also, the LAN IDs administrated by the customer. The length of IPv6, which is 128, makes the remembering of this representation is too difficult. This is why we need the shorthand notation of v6 or a compressed notation of v6. For example, here we have original address started by 2041 and ended by 131b. Three rules are defined for implementing the shorthand notation of v6. The first one, omitting string of zeros. When you have multi-parts of zeros, neighbors, here we have 12 zeros as 3 parts in the same IPv6 address, can be replaced by 2 colons only, as appears in the first line. Then the second rule, omitting 4 zeros and leave single zero. Go to the part that contains all zeros, here the second part of IP address, and replace these 4 zeros by 1 0. The last rule for shorthand notation of v6 is omitting leading zeros. It means delete or omit any zero on the left hand side of each partition, which is not significant for the address part. Here we have examples, shows the complete IPv6 address representation compared to the compressed one. Let us describe IPv4 and IPv6 in terms of protocols and headers. The comparison here shows the colors for each type of field correspondence between v4 and v6. The yellow one, the yellow fields in v4 header maintained as the same name kept from IP version 4 to IPv6. It means they remains the same as size, as name and position, but the size may be different. For example, here source address 32 bits corresponds to source address 128 bits for v6. Fields not kept in v6, it means deleted, appears in v4 but deleted in v6. All red fields, for example IHL, identification, flags, and options padding, all these fields, red fields, are omitted in v6. The blue fields distinguished by change in name and position from v4 to v6. For example, type of service in v4 corresponds to a traffic class in v6. The name is changed, and maybe also the position is changed. For example, time to live in v4 corresponds to hop limit in v6. Here the name change and the position as a sequence of fields is changed as well in v6. The last one is the new field in v6 created, which is flow label of v6 header. As an example of v4 and v6 subnetting, here we have many subnets appears in v6 with 16-bit started by 1000 ended to F0000. Also, we have here two subnets, A and B, each subnet represented by an IP version 4 class C with different network part as class C, and IPv6 uses the same site address ended to 0 before the 12 and before the 23. It means the v6 here, the two v6 addresses here belongs to the same site address, but they use different subnet, two different subnets, 12 and 23. Another example to classify the major view of IPv6 as addressing. Here we have a topology with 4 routers. Let us focus on addressing part of the topology. The upper one here, which is 2001 DACA1/64. This is a IP address. The /64 represent the network part. Compare it with the left address, which is 2001 DACA2/64. It is easy to distinguish between them by 1 and 2, the difference. It means the first 32 bits are the same. They belongs to the same ISP, but they use different site. The upper address represents site number 1, and the left address represents the site by the number 2. Also number 3, then 4, then 5, then 6, then 7. It means all addresses here in this topology example uses the same first 32 bits, which corresponds to the ISP part, but different sites from 1, 2, 3, and 4 till 7. This is part of the management for addressing in V6. Our lab tutorial and the next videos will shows tutorials about connecting two PCs using link local address, then connecting these two PCs to the router, then another network created, then adding the Unicast address to the router to process or forwarding the packets from each subnet to another. Thank you. This is the references of our presentation, and thank you.